Hi, it's Alyssa from Math for Elementary Teachers. Today I'll be doing the Chapter 13 Teach It assignment. I'm going to be doing problem number 13, parts A, B, and C in section 13(1)(b). So to start, we're going to look at a few definitions before I turn the camera around. So a couple definitions that we'll need to know to do this problem is the definition of rotation. So rotation is a transformation of the plane determined by holding one point, the center, fixed, and then rotating the plane about the point by a certain angle clockwise or counterclockwise. And that'll make a little more sense once we get going with this. And then the second one is a perpendicular bisector, which is a line that's perpendicular to a segment and then it bisects it. So it pretty much means that it forms a right angle at some point in there. So I'm actually going to turn the camera around and we're going to look at the problem. So here is problem number 13. And part A says refer to the following figure and use paper folding or any other method to show that reflected P is the image P under rotation about point O by a given angle. Then O is on the perpendicular bisector of point PP. So this is the image here that we're trying to prove, this one right here. And I've kind of drawn out a rough version of this with this piece of paper. So what we're doing is we're looking to see that when we rotate point P, like we talked about with our definition, that it's going to reflect over here. And we're going to do this by folding this piece of paper. So here I've got point P, and I'm just going to fold my piece of paper over right here. And I'm going to scrunch it down here to form a definite line. And we're doing this around point O, which is right here. So when we folded it over, we could tell that point P is on the exact same line as the original point here, so this is true. And that O is actually on the perpendicular bisector because this line is perpendicular to and it bisects this original line. And we can tell this because it forms a strong right angle here, regardless of my drawing, but it forms that strong right angle, which shows that when we reflect this point P onto the rotational point P here, around the point O, that there's a right angle formed, which means that there's a perpendicular bisector. So point O lies on the perpendicular bisector here. Let's go to part B here. And it says the reflected triangle ABC shown in the following figure was obtained by rotating the original triangle ABC about a certain point O. Explain how to find the point O and the angle of rotation. So this one is a little bit harder to show you, so I'm just kind of going to explain it and use my finger to help you out here. So to find point O, we need to find the point directly between these two triangles. So if we had graphing paper or a piece of paper with like points or something on it, we could find that direct center. But for right now, I'm just going to use my finger to kind of like point it out. It's going to be right about in this area. Once that point is found, we can verify it's correct by rotating the triangle and making sure that it rotates and makes this rotational figure the correct way. So what we would do would we would just rotate this triangle right around point O and get this figure here like we had over here. And then to find the angle of rotation, which is the second part right here, we can be found by using a compass to find the correct angle from point O, which was that point that we just talked about, to any given point on this triangle here. So say from point O to point A, and then the angle of rotation would follow this point A all the way over here to this corresponding point A over here. And this angle that's formed would be the angle of rotation. So as you can see, that point O is very important as it tells us like where to start and then where to finish. And then we definitely need to use those corresponding points. And it makes a difference that the triangles are congruent because, again, same size helps us out there. So then let's move on to this final part here. It says triangles ABC and then the rotation reflected triangle ABC are congruent. Trace them and explain why it's impossible to find a rotation under which triangle, the reflected triangle right here, ABC, is the image of the original triangle here. So again, I have a second piece of paper here that we're going to look at. So here's the original, and then here's the reflected one, or the rotational one. And we can see that if this was the point of the center here, the point O, give or take, for this triangle to rotate around, it would definitely, it's not going to work because these points are not, they don't coordinate together. So point B here is point B here. If we were looking at this actual point of origin, say right in here, point B would actually end up being where point A is on this rotational triangle. So it doesn't coordinate because points B and A in this rotation triangle are actually flipped. So because that these points are flipped, there's no way to find that rotation that works for this specific example. If, however, we had the triangle and we rotated it around this point, and point B was over here, then we could find that angle of rotation and it would be possible to find that rotation that worked. But because these points don't coordinate, it's showing us that there is absolutely no way for this triangle to rotate over this way, because you'd have to flip these points around, and that's not what we're being asked to do. We could even try and go around this way, and we could get point A up here and point B down here, if that makes sense. So I moved the camera, but if we went around this way, it's still not going to work because point A is actually going to move right up here, whereas point B is going to move right down here. And point C will stay the same, but it's because of these 2 points not coordinating to these 2 points that this example is not going to work. So thank you for watching the Chapter 13 Teach It video. This was problem number 13 in section 13.1b. Thanks for watching.